we'll go ahead and do a live demo here. And if folks are interested, go ahead and take out your laptops, follow along. If you utilize auto-scaling, can you change the instance size? Can you move from like a smaller to a larger instance? Amazon's auto-scaling doesn't do that natively. There are some tricks depending on your use case where you could accomplish something like this. But if you have a VPN appliance and you would like to move to a larger VPN appliance, you're not going to be able to easily use auto-scaling to do that. The other question is, can you use Amazon's auto-scaling to improve availability of a single node? And the answer there is yes. If you use an auto-scaling group with a minimum size of 1 and a maximum size of 1, Amazon's auto-scaling, if you lose that node, if that node has something that goes wrong, Amazon will actually build a new node for you. So this is a very cool trick with auto-scaling. Min size 1, max size 1, desired capacity 1. If the node ever goes away, Amazon builds it right back. You have kind of self-healing infrastructure that way. So if you had an availability problem with your VPN appliance, you could say if the VPN appliance isn't answering on port X, go ahead and terminate it and build me a new one, and a new one would come back up. So the health checks are either EC2 type health checks, and an EC2 type health check, what that does is that asks Amazon, is the machine healthy? And that's going to, there's some specifics in there that actually I don't believe Amazon's released, but I believe that the EC2 type health check will test for port 22 being open, and it will also check the underlying infrastructure, like the underlying infrastructure for health. So that's EC2 type health check. There's also an ELB type health check. The ELB type health check will either look for a port or will look for a specific URL. And if it finds that URL, and actually if it requests that URL and gets a 200 response back, then the load balancer and the auto-scaling group knows that it's healthy. So what you can do is you can say, does Amazon think the node's healthy, or does the load balancer think the node is healthy? If you're running web servers, it's a good idea to at least experiment with the ELB health check, because then what will happen is if the node's not healthy, it will terminate the node and a new one will come back in service. There's a little bit of danger here. If you use ELB type health checks and the node is very busy, or like Apache is overloaded, you run the risk that the load balancer attempts to query the given URL and fails, not because the instance is unhealthy, but because the instance is simply too busy to respond. So you're already at capacity, you have nodes in service, and then they're actually they're CPU constrained at that moment. You go ahead and request a resource, the resource is not returned, and then auto-scaling terminates that node. So the very moment you need more capacity, Amazon's busy terminating the machines that you need. Be careful with this one. At this point, if folks are interested in building auto-scaling groups, go ahead and sign into AWS and follow along. So the first thing that you're going to do when you create a auto-scaling group is actually create a launch configuration. The launch configuration is going to tell the machine what to do when it comes up, and the launch config lets us define what type of instance we're going to be running. In this case, I'm going to be using an Amazon Linux machine, but you could just as easily use like an Ubuntu machine or something similar. Your auto-scaling group will be comprised of instances of a particular type. In this case, I'm going to utilize the T2 micro instance type. So yeah, if you have custom AMIs, you can use custom AMIs with Amazon's auto-scaling. And I'll show you how to do that. Right here, rather than selecting one of these kind of default Amazon AMIs, what you would do is you would actually go over here to My AMIs, and you would select the AMI that you had created. So this right here, where it says request spot instances, if you were willing to delay or to bid on Amazon instances and perhaps get them, you could go ahead and click request spot instances and bid a particular price. So I'm not going to use spot. And then here's the magic of, or one of the kind of magic pieces of Amazon. Right here, what I'm going to do is I have a very simple shell script. And what this simple shell script is going to do is when the instance is actually booted, this shell script will run. In this case, I just install Apache, but you could have this do anything you wanted. You could have this script right here, which I'll show you how to inject into Amazon's auto-scaling. You could have this script call out to Chef, call out to Puppet. I know we have no Salt users, but you could call out to Salt if you used it. But this is how you build your machines using Amazon autoscaling if you don't bake AMIs. So I think we have a few folks in here who bake AMIs as well. So what we'll do is we will go ahead and just copy and paste this right in here. So I've already created autoscaling groups, so I'm just going to use the www ASG autoscaling demo group. Or security groups, yes. The detailed monitoring for CloudWatch is actually required for a little bit later on in the demo. What I'm going to do is I'm going to scale machines into service after a minute. So what this does is this gives me more granular metric tracking. So rather than 5 minute, which is the typical metric production time, I'm going to be using 1 minute metric production. That way I can scale more quickly. Otherwise, people would be sitting around for 5 minutes waiting for machines to scale into service. With auto-scaling groups, you actually don't need to expose any ports. If you're using a load balancer, you would probably, well, if you use with a load balancer, you need to allow the load balancer in, but auto-scaling, you don't really need to allow SSH in even. You could just have these machines run as like complete appliances, no SSH, and just have them scale in and out of service and never log into them. If folks work with like engineers who like to hop on prod boxes and change settings around or something like that, one, you can lock out SSH, and two, with auto-scaling, those boxes that have been tampered with, those are going to be pulled out of service at some point, and new ones will be brought in that are clean, which is kind of nice. If you ever encounter like a tampered with box on Amazon, just go ahead and terminate it. A new box will come right back up in its place. That's our launch configuration, and this is going to be used by an auto-scaling group, and the auto-scaling group is going to say, you know, you have 1 instance, 2 instances, or more instances. So I'm going to go ahead and start with 1 instance. Let's say I'm just kind of prototyping something, and then we'll scale from 1 back up to 4. Cool thing about EC2 VPC is you can change instances security groups. If you're in EC2, if you're in EC2 Classic, you can't actually change the security group for an instance. So if you launch an instance and you say, hey, you know, you're a member of the like security group, and then all of a sudden you want to say, cool, I want this machine to be a member of 2 security groups. With EC2 VPC, you can do this. EC2 Classic, you cannot. And then the last part of this, so I'm going to build an auto-scaling fleet of web nodes, is I'm going to connect this auto-scaling group to a load balancer. And then for tagging, for folks who are interested in like identifying how much Amazon spend or where they're spending, this is a great opportunity to tag instances. I've gone ahead and created my auto-scaling group. You can see the group right here. Right now, there are no instances in service, but I have a desired capacity of 1 and a minimum capacity of 1. Amazon's going to respond to this by giving me a node. And voila, we have our first node. The next thing that's going to happen, because of the way this auto-scaling group is configured, it's associated with a load balancer. I can go over here, and I can look at my load balancer, and I can see that at the moment, I have 0 of 1 instances in service. Once the load balancer recognizes that the machine is running properly, it will bring this node into service, and then we've built a very basic auto-scaling website. So here I'm logged into my first auto-scaling node. This may be a little bit hard to see, but Apache is running. And let's see what our load balancer says. Our load balancer has identified that the machine is running Apache, and the node is now in service. So now if I go to the load balancer, I have that very simple page that I created when I implemented when I implemented the user data. You can see this. And you say, Colin, that's great. You built a machine, and it took you like 25 minutes. You say, I'd like to see a bunch of machines. So let's do it. Jason, do you remember the bill you got for maybe $400 a while ago? It's one of these demos right here. So what we're going to do is we're going to change the desired capacity right now to say 6, and the maximum capacity to 10. And about 2 or 3 minutes later, we'll have our 6 instances. So you can see Amazon's responded. And how has it responded to my request for 6 instances? It's launched additional instances, and we know what's going to happen with these instances, right? The instances are going to come up. They're going to register with the load balancer. They're going to run the user data script, which is going to install Apache and configure the very basic page that I had served. And then the load balancer is going to recognize these instances as healthy. And our load balancer now says that, oh, we have 1 of 5 instances in service. Very shortly, we will have 5 of 5 instances in service. Now you can see if you were like a developer or even an operations person and you were trying to SSH into all your prod instances, how this would be a little unnerving, right? Just a minute ago we had, or if you were configured Nagios to monitor nodes or something like an Nagios, just a minute ago we had 1 node, now we have 5. In another minute we're going to be back down to 1. The other cool thing to note, as promised, Amazon has distributed these nodes across different availability zones. So here, you'll see that we have 2 machines in 2A, 2 machines in 2B, and 2 machines in 2C. So Amazon has taken care of distributing nodes across availability zones for us. This is very nice. So all the nodes are in service, which means if I request this page right here, what we should see is the instance IDs changing as the load balancer routes traffic to the different nodes, and we should also see that their local IPs and public IPs change. This machine is instance ID ending in CE. The next machine is instance ID ending in 1C. So just so I don't run up a huge bill on Jason's credit card, we'll go ahead and scale back down to 1 machine. Amazon places caps on your account. So if you need to go past, like, say, 25 machines or 25 auto-scaling groups, you need to call Amazon up prior and say, look, we're going to bust through this limit. We'll go ahead and scale back to 1 instance and a max of 10 as well. In many cases, like 99% of all cases, Amazon will give you the desired capacity. And you say, well, what are the cases where Amazon won't give you desired capacity? Say you need more web servers because of like an iPhone launch or something like that, and you need to serve ad traffic. Right then, there may be a lot of other companies that also need to serve web traffic. So Amazon may deny your request because they're out of capacity. Quick little kind of trick, if you know that something like this is going to happen, spin up additional instances, meaning change your desired capacity, well in advance of the event that's going to be happening. That way you get the capacity before somebody else. For particular events, New Year's Eve was another one for Lyft. We spun instances up about 2 or 3 days in advance and just paid for it. That way we knew we wouldn't have to request additional capacity on New Year's Eve. If Uber used Amazon's auto-scaling as well, we didn't really want to be competing with them for instances on New Year's Eve. They don't, so Lyft survived New Year's Eve, and I don't know if anybody tried to get an Uber on New Year's Eve. I'm not sure. Maybe people didn't want to pay surge pricing.
So then what does the min do?
The min ensures that you always have a particular number of instances. So if you have a minimum of 0, you could actually have an auto-scaling group with no machines. Does this make sense? Cool use case here. You can set the minimum, maximum, and desired capacity all to 0, say in an evening when like QA isn't working. You can zero all this out, or you can use a scheduled scaling event in order to turn nodes off at a particular time. If you know that people are going to be using an environment from like 8 a.m. to 6 p.m., you can use a scheduled scaling event and say, in the morning, scale up to 1 or scale up to 4, and then in the evening, scale back down to 0. So that's when you would use min, max, desired, all 0. But min is exactly how low they can go. We'll do 2 more things, and I think we're going to wrap up at about, let's say, 12:40, 12:45, after which I'll hang out, take questions, help people implement auto-scaling, whatever you guys would like to do. With an auto-scaling group, you also get something called an auto-scaling policy. This is where like the auto scaling happens. So the first policy we're going to add is going to add nodes when a certain event occurs. In this case, what we're going to do is we're going to add nodes when CPU utilization hits 50%. Do folks have machines that hit 50% CPU utilization? Yes. And do folks wish they could scale other machines into service when that happens? Maybe. If you use a load balancer and SQSQ, you certainly do. Do folks use CloudWatch? A couple of CloudWatch users? Okay. So the trigger for the scaling policy that I'm about to show you is actually a CloudWatch alarm. So anything you can alarm on in Amazon, you can actually use to scale more machines into service. So what I'm going to do is I'm going to say when the average CPU utilization across my entire fleet of Amazon instances is greater than 50%, please add another node. You could go as high as 70. For me today, for the purposes of the demo, 50% works perfectly. I would suggest, depending on what your workload is and how quickly you need to scale, you might use something like 70% instead. So you can like delay auto scaling. You can have auto scaling postponed because previous auto scaling events occurred. There's a couple of different options here. For the demo today, what I'm going to do is I'm going to scale kind of breakneck speed. So what I'm going to do is I'm going to say if CPU utilization is greater than 50% for a period of 1 minute, give me more machines. In a production environment, you might do something like, greater than 70% for 2 consecutive periods of 5 minutes each, and then you would scale a little bit more slowly. There's some companies that have found challenges doing this and scaling correctly. They just over-provision. For instance, Netflix just runs extra machines. They were having trouble scaling correctly and scaling quickly enough, so they just said, we're going to take whatever the number of instances we think we need and just add 1 to it. So they scale early and they over-provision. So here I've created my scale up policy, and now I'm going to create a scale down policy. One policy to remove instances when CPU utilization is less than or equal to 20%. And we have another policy here to scale up. So now what we're going to do is we're going to log into the first instance, and we're going to generate some CPU load, and we're going to watch the auto scaling. We're going to watch the alarm go off, and we're going to watch the auto scaling trigger fire. So now what we should see is an increase. What we're doing is we're stressing one of the CPUs in the auto scaling group, and what we should see very shortly is that this alarm, the scale up alarm, is going to be triggered, and we will scale additional nodes into service. One thing we're going to do is we're actually going to decrease the desired capacity to 1 so that the alarm will actually fire. I was utilizing the CloudWatch alarm that says across all machines, trigger the alarm if I have greater than 50% CPU utilization. If I have 3 machines and only 1 is stressed, the highest my CPU utilization can get is 33%. You'd never see the alarm, and then I would never scale back up to 2. So in another minute, this should jump back up, and now we should scale. After that, I'll do kind of the last trick of the day. For the last trick of the day, what I will do is I'll use, do folks here use CloudFormation? Terraform, a little bit of CloudFormation, yes on CloudFormation, no Terraform, no Troposphere, anything like that? Troposphere, yes, okay. So the last thing we will do on today is we'll use Amazon's CloudFormation, which is an infrastructure provisioning tool, and we will use that CloudFormation file to scale up infrastructure in Amazon's West region, its East region, and its West 2 region, and we'll build load balancers, auto scaling groups, and everything, all touch of a button. So you'll be able to provision the entirety of your infrastructure, or in this case, a couple of web servers, load balancers, et cetera, all touch of a button, and actually all in brand new VPCs. So you can see here we touched 49%, and we're at 99% CPU utilization on this node. And here we go, 80% CPU utilization. So this is a pretty bad situation, right? If you were 80% CPU utilization on 1 node and that was it, you'd probably want to scale up, so you'll see that very shortly. We've just passed the 50% threshold, and in response to that, if we go look at our auto scaling group, the next thing I'll do is I'll show you guys how to use CloudFormation to just build lots of auto scaling groups very easily. So CloudFormation is Amazon's tool for provisioning like lots of resources and connecting them. So in this case, CloudFormation is going to provision what they call a number of resources. It's going to build me a brand new VPC, which you'll see right here. And the more important part is it's going to build me a web server launch config, and it's going to build me a web server auto scaling group. This will be 3 web servers in US East 1. Then I can move to Oregon. I use this same exact file. I'm going to build 3 servers in Oregon. So in about 5 minutes, in 3 of Amazon's regions, we will have web servers, load balancers across US East 1, US West 1, US West 2. All provisioned, same file, in probably 3 or 4 minutes tops. Does anybody want to go back to managing data centers after seeing this? Does anybody say, boy, I'd really, really like to build out a data center in, say, like Las Vegas, and then fly to like Virginia to manage a data center? Do you remember the user data script that I showed you? That user data script is very fast, right? All it does is it cats out a file, it installs Apache. So that takes something on the order of like 2 or 3 minutes, right? If you had something much more complicated going on when you scaled nodes into service, like you wanted to install Puppet, register with a Puppet server, apply Puppet configs, you might be talking on the order of like 10 or 15 minutes in order to scale new nodes into service. Folks typically work around that by baking AMIs or something similar. Last thing we'll do, we'll go check on the auto scaling groups that I spun up in every region. We'll go check the load balancers to make sure that all the nodes are behind them. And then I'm available for questions. So here's our first set of auto scaling groups and our first load balancer. In this case, they're in the US East 1 region, but there is the auto scaling group and load balancer in the US West 2 region. I'll take questions. I'll be available. There's some other folks here as well, like Joe's Amazon certified, definitely willing to help answer questions as well. So I want to thank everybody for attending. And if you've got questions, feel free to let me know.